Welcome, everybody. Welcome to our last Ask a Geologist of this academic year. We are here today to look at the research of Dr. Rosana Grafals. She's Rutgers alumni that came from the University of Puerto Rico in Rio Piedras, and she graduated from the Department of Geography in 2010, and she's currently at the University of Puerto Rico in Cayey as a full professor. And today she's here to talk to us about coastal geomorphology. And with further ado, we are very happy to welcome Dr. Rosana Grafals Soto. Thank you so much for being here today. And the floor is yours.
Hi, thanks for inviting me. I'm very happy to be back at Rutgers, even with a virtual setting, right? I have a lot of great memories of Rutgers and a lot of great experiences. So I am a coastal geomorphologist, and that my favorite place definitely is the beach. Is the place where I feel at home, and it's also the place I do research in. Um, I'm a geographer, so when you say coastal geomorphologist, geomorphology is a branch of geography. So I'll talk to you a little bit more about what a geographer does in a little bit. And I am definitely convinced that rocks and sediments have a way of talking to us. When we look at them, when we study them, when we observe them, when we analyze them, rocks and sediments have a lot to tell. So we can learn about where they come from and how they got there, and there's a lot to learn from them. So it's like they're talking to us, right? At least for me, it is. So what is a geographer? Is someone who thinks spatially about people and about physical processes. So when I say spatially, I mean different spaces. You can differentiate what happens here from what happens there, and so space is the subject of geography. You think about space. Uh, and and its characteristics and what it is like and what it used to be, all those things. That's what a geographer studies, right? And so we identify characteristics, we compare them, and those comparisons can be done through space. You can compare different spaces, or you can compare the same space over time. So there's a spatial, but there's also a temporal thing about geography. And so there's a lot of history involved too. You know, geography is not history, but we do use a lot of history to understand the different spaces that surround us. And so our main question is where, right? If you ask a historian, his or her main question will be when, right? When did this happen? But we ask where it happened, right? That's the main question. And then after that, we ask how, or we ask why, right? So where is the first question that comes to mind when you think of a geographer? Now, when you think about coastal geomorphology, and you can think about geomorphology in itself, but there's a lot of different geomorphology kinds, right? Geomorphology is just the study of the shape of the earth. Uh, what is that shape like, right? And the word says it, right? Geomorphologist, right? The study of the shape of the earth. And now when you think about the shape of the coast, right? When you think about that, then you are analyzing and explaining the shape and the processes of a specific part of the surface of the earth, right? You're thinking about the coast, about the shape and the processes of the coast. And so what do I do with that? Well, I identify what it looks like. the characteristics the coastal space landscape has. I describe what were the processes that allow for that space to be the way it is now. And I compare and I explain what those processes are like in different spaces, in different landscapes. Or I can also explain what are the interactions between different systems, for example, the beach and the dune. And we're going to talk about the dune in just a little bit. And or I can explain what's the relationship between different processes on the beach, different locations. I can identify different zones. I can think about the sediment in itself, where it came from, how it got there, etc. And so one of the things that I think about a lot is how do people use the coast? How do people modify the coast? How are we influenced uh, as a society by the coast? And what are the things that we do that modify or change or influence or somehow affect the processes that allow for the beach and the dune or the coast in general to be the way it is? Because we use and we need the coast. We live in it, right? So that's something very geographical. When you think about geography, you not only think about the coast and its physical characteristics, but you also think about the landscapes, in this case, the coast. You think about it in terms of the people, right? That's different from geology, right? Geology involves more natural sciences. That would be the physics and the chemistry of the sediments, and the physics of the and the chemistry of the wave action, for example. An oceanographer would take a look at that. But to me, I'm more interested in the people, in society, how society is involved in these landscapes, and how there's a reciprocal interaction between those physical processes and us. So that's a very important question right there. And so this right here. And so when I choose between different landscapes that I can study, when I was deciding, I decided to look at dunes, coastal dunes, because there are dunes in other landscapes in the world, but I'm looking at coastal dunes. And what are those, right? You think about dunes, and what is a dune? Well, when you think about a dune, you have to think a coastal dune specifically. You have to think about sand accumulation on the back beach. And how did that sand get there? Well, it got there through wind erosion. And when you think about erosion, you need to think about transport. You need to think that the sand is moving to the back beach. The sand is relocating, right? So all of this happens through wind erosion. And that's important for us to know, because a lot of people get confused and think that dunes are formed by waves. And waves and currents are important for beach formation, but waves and currents don't build dunes. Dunes are built through wind erosion, and that's also called aeolic transport, right? If you've heard of that word, aeolic, that means there's wind involved, right? So in the case of coastal dunes, there's wind action happening, and that wind is moving, is transporting, is eroding the sand to the back beach. So what do you need for dunes to form? You need sand, of course, and that sand needs to be very fine, very small. There's different sizes of sand, right? And all of sand belongs to a specific range of sizes, right? After it becomes too big, we call it gravel, right? But there's not all sand is the same size. And the kind of sand that we need for the dunes to form is the kind of sand that the wind can move. And so it has to be very fine, and it has to belong to a wide beach. And why do we need a wide beach? Well, the big wide beach provides a source of sand, but it also provides space And so a lot of people don't think about that, but when you are thinking about coastal dunes, you need beach space. You need space on the back beach for that sand to accumulate, right? And for the dune to be wide enough to become a stable dune and to be uh, far enough landward for the waves not to hurt it, right? Or change its form too frequently, right? Because otherwise it won't stay very long. And so you also need a constantly onshore strong wind. You need wind to be strong enough to move the sand, and you need that wind to be onshore, right? From the ocean towards the land. That's what onshore means. And so when you have that kind of wind, you're going to have all the sand from the beach moving landward. And that's the kind of wind that you need. You need that to be constantly strong, at least for some part of the year. In New Jersey, for example, in the winter, you have very strong winds, and that's a moment during the year where you have a lot of, where you could have, right, a lot of dune formation happening. And so we talked about space. We need a lot of space, and we need time. A lot of people don't think about time either, but we often get very impatient with physical processes, and all these dynamics need time. You need time for the sand to move. You need time for these onshore strong and constant winds to happen. You need time for the seasons to change, for the vegetation to grow. All of that you need for dunes to form, at least when you want them to form through physical processes only, right? So that's important. Don't rush it. We need we need time for the dunes to form. We need to be patient. That's something that all of us should practice, right? Patience. So wide beach with fine sand, strong winds that move onshore, and space and time. That's all you need. And once you have that sand moving, you're going to need a barrier to stop it, right? Because otherwise, all that sand is going to keep moving. Oftentimes, that barrier could be the dune itself, right? Or it could be sediment. And sometimes when we want things to happen a little faster, we put fences on the beach. And you probably have seen sand fences on the beaches in New Jersey and in other places in the eastern side of the US, eastern coast. And those fences are usually there, or oftentimes are there for to accelerate the process of dune building because they become barriers. So how do I study coastal dunes? What do I do? Well, first thing I observe my surroundings. And one of the things that my advisor at Rutgers used to tell me was you need to go to the beach. You need to go to the dunes and look at them. You need to go take a look at what's happening there, see what's interesting to you. So that's the first thing. And after that, you look for information and you read and you write. You read a lot. And so this is one of the things that people forget about research. There's a lot of reading and there's a lot of writing. And people usually focus on the fun part of going to the field and being at the beach and discovering new things and taking a look at the waves and the sand and gathering the data. But first you have to read, and you have to read a lot. And you have to read because that's how you know what's been done before. That's how you know what's going to be your new thing in this research that you're doing. What's going to be your what you're going to produce. What's the new thing that you're going to produce based on what's been done before. That's the way you can justify when you read the information that's been done before. That's how you justify the way that you're going to gather your data. And when you're done with your research, you can say, I did it like this because that's how it's been done before, or this is an adaptation of what's been done before. And so that's why it's so important to develop those reading and writing skills. And so after that, or while you're reading and writing, you also gather data in the field. And And when you go to the field, you wake up really early in the morning, really, really early before the sun's out, and you go out there and you take all your instruments and you measure the width of the beach, the width of the dunes, their height, the types of vegetation, their location, the waves, the wind, etc. All those things. You do that in the field, but you can also take a look at and gather data from aerial images. And I don't know how many of you have Google Earth in your computers or maybe in your phones. Um, Google Earth is a really handy geographical application that you can have. You can go anywhere in the world without being in an airplane by looking at Google Earth. And so in this image I took from Google Earth, you can see Ocean City, New Jersey. I assume many of you have been there. And this is from 2006. And what do I look at how do I gather data from aerial images? For first, I identify what I'm looking at, right? From knowing this is Ocean City, I can identify this is the Atlantic Ocean. And I can see also the waves breaking right here. And I know these are two different environments, the ocean and this other environment right here. I know that's the beach, right? I know it from the color. I know it from the breaking waves. I know it from the location also. And so I can measure the width of the beach. And I can also take a look at these oval shaped um, features right here. If you look at them, what would they be? What do you think? Hmm. Well, these are dunes, right? These are coastal dunes that we have in New Jersey. That's what they look like when you take a picture from a satellite, right? That's what they look like. And I can also identify the vegetation on them. You can see that their color is different from the beach itself. I can see this pier right here. I know it's a pier because it's perpendicular to the waterline or to the shoreline. And I can see also streets and houses with their rectangular forms. And all this observation exercise is a geographical exercise. You are identifying shapes, sizes, you're identifying by association from one space with the next. And so when I look at this, I can compare this space, this location with another place, with another time. And I can realize when I take a look at this other photograph or aerial image, right? This is from the same exact location in 1995. That's 11 years before in Ocean City. And what do you see here? There's something different. I can see the pier still there, but there's something that's not there, right? Do you see the dunes? The dunes are not there. So we are used to the landscape being the way it is right now, but we have to remember that there's changes that happen over time, decisions that are made over time, because these dunes are not entirely from only from physical processes. Their shape and their size and the spaces between them, all of those are made by people, right? By decisions that people have made. And so someone decided that Ocean City needed dunes. And that's when history comes to play, right? That's why geography is so interdisciplinary, right? I'm talking about some things that can be geological and some things that can be historical and some things that can be sociological, right? When we think about people and the coast and the relationship, or maybe some things are psychological. Why do we choose to go to the beach, etc., right? So I can compare the same space over time and I can come to explanations of why things are the way they are now and why did they change. So you gather temporal data by using images. And so this is really important and it's a great tool. You don't have to go to the field to do that. You go to the field afterwards, right? To corroborate certain things and to maybe study the sand itself, which cannot take from an image, right? Or to talk to people and interview people that you would do by going there. But there are things that an aerial image gives you, information, data that you can get from this aerial image that are really interesting and that can be really helpful when you do geographical work. So why is this important? Why should I care? Why should you care about this? Well, because we live and we enjoy and we use the coast. We need it. We have to understand its processes, to use it safely, to allow for its dynamics to endure, to allow for the beach to keep being what it is, to protect it from storms, to protect us from storms, our houses and our livelihoods. And you guys had a storm, right, in New Jersey, this big storm, Sandy. And Sandy left a lot of devastation on the coast, and I'm saying that, but you know that because you lived it, right? I was here in Puerto Rico. You were there. You lived it, right? You can tell me stories about that. And so when you look about at Ocean City, how it was before the storm, you definitely notice dunes, right? And the buildings and the parking lots, etc. And then when you look at an after photograph, you notice that all of this was washed out. And this is nothing, right? I'm showing Ocean City is a space that might not be as devastated as other locations, but what I want you guys to look at is that there are certain things that the landscape can tell us. And so you say, well, the dunes were there probably to protect the buildings in the back, but they didn't do their work. And you're like, ah, those useless dunes, right? But when you look at this and you realize what the dunes are shaped like and what the dunes were experiencing during the storm, we think about wave energy and we think a lot about a lot of water going inland. And so where could the water move through? Like what are the locations where the openings that the water could have used to move inland? Or you do have a lot of openings here. You have the entire street and you have a small boardwalk right here. So there's something about the design of these dunes that needs to be rethought, right? If they didn't work for what we wanted them, maybe we need to make them wider. Maybe we need to change these openings right here that allow for water to move inland so easily and to wash out all of this sand inland. So these are the kinds of comparisons that we can use as geographers to understand and to make decisions for the future. What am I doing with this now? Well, I used to work with temperate environments such as New Jersey back in 2010, but now I'm moving to the tropics, and here in Puerto Rico, I'm looking at what are the locations of dunes, where are dunes at, what are the municipalities, and the municipalities are these polygons that are colored in brownish color. And all these dots that you see right here, these red dots, are the locations of the dunes. And all of those municipalities have dunes right now, but there are some locations that meet the criteria for dune formation and that don't have any dunes. So that's something that could be used to mitigate storm wave action, because we do have a lot of storms too. We have hurricanes, we have storm surges from storms in the northern Atlantic that happen in March very often, and also in October when it's still uh, somehow colder in the northeast of North America. And so that's what I'm looking at. For a long time, people thought that there were no dunes in Puerto Rico, but there are. And that's what I'm trying to challenge right now, to have all of that information so that can change and that we can use dunes for mitigation purposes. Mitigation of what? Well, wave action and inundation and flooding in the coastal areas, and to protect the people that live and that use um, these spaces, that it's a lot of people, especially in an island, a tropical island like Puerto Rico. So it's question time. I hope you guys have enjoyed this talk. Let me, should I, should I take this off or
Thank you,
something?
Rosanna. Yes, you can stop sharing your screen and
Okay,
you can go into the Google Docs and see the questions, but you don't
okay,
have to share that. Now
okay.
it's a conversation with you.
Let's see. I'm not sharing, right? Okay. I see there are a couple of questions here in the, there's one question in the chat. Should I take that first?
Yeah, you can take that one first.
So there's a question here and says, did the geographic of the beach change after Hurricane Sandy? I don't have data on that specifically, but I would assume it did. The geomorphology, definitely the shape, the width, the height, the amount of sand, because a lot of sand moved landward. So there was a lot of erosion and a lot of sediment moving here and there. So I would assume it definitely did change after Sandy. There's another question here that says, I have seen where areas along the New Jersey coastline have planted coastal brush and subsequently the coastline has been building up. Yeah, sometimes there's certain plants that are very useful for sand accumulation. The important thing is to choose wisely which plants for which purpose, right? If we want sand accumulation, which are the plants that are most likely to help with that, and where on the beach should we put them? Because not all the places on the beach are suitable for to accumulate sand by the wind, right? So we have to be careful about that. Which plants and where we put them. Um, can marshlands be planted in coastal dunes to prevent waves? Um, Marshlands, do you mean um, vegetation like marsh? If you mean marsh type vegetation, um, that's tricky, right? Because we need to pick again plants that are suitable for being buried under the sand. And usually in marsh plants are plants that can be inundated or flooded. And so those are not very happy when they get buried by sand. So yeah, we need to pick plants that don't mind being buried and actually need being buried to progress and to grow. There's another question here that says, I see that you're currently studying the coastline in Puerto Rico. Where else have you studied the coastal dunes? Um, I've studied New Jersey, of course. I've also been to other Caribbean islands that include St. John, or was it St. Thomas? Now I'm confused. I can't remember which of those it was. St. Martin and Barbados, and what was the other one? St. Kitts. St. Kitts, yeah. And of course, when you read about all the places in the world and what they're doing. But right now, I'm trying to focus on tropical spaces because the conditions for dune building are similar, but are not entirely exactly the same, especially with vegetation. In tropics, you have vegetation growing all year long, and in temperate areas, latitudes in the 30s and the 40s degrees in latitudes, you get vegetation growing a lot only during the summer, and so that's important in terms of dune building. Okay, so I see here questions about the sand. It says, is the word sand only used for particles that come from stone? Well, sand can be made from many different things. You can have sand, yeah, from coral. You can have sand from Sand is just particles, right? It's a kind of sediment, a kind of sediment. In this case, we find it on the beach. You can also find it on the desert spaces. Um, it's sediment that's been worked, or maybe rocks that have become smaller, but they come from a lot of places, from under the ocean, from rivers, from inland, from coral. Um, so there, I would say it's more about the particles, the size of the particles. That's how you know what sand that is sand, and for example, not gravel. Do sand dune particles change size from larger to smaller? Yes, there's a range. There's a range of sizes of sand, and and they can uh, become rocks. Definitely, sandstone is the I'm thinking in Spanish right now. Um, the consolidation of sand particles. So when you think about sandstone, it's a lot of sand that has become cemented and consolidated. When sand dunes just sit there, do the particles move downward? Well, they are. It depends. If it's a sand dune that's vegetated, usually the vegetation keeps the sand in place. If it's a sand dune that's not vegetated, the wind moves the sand. If there is no wind at all, then gravity would be the main mover of sand, right? Um, what else? What new tools or tests would you like to have for your research? Oh, well, maybe not a tool, but a an expert in satellite images. Someone that could help me uh, do some aerial analysis. There's a lot of cool stuff that you can do with different kinds of images. I only showed you a regular, aerial image, but there's all kinds of aerial images that can give you information about elevation, for example. And it takes a lot of time to become an expert on that. So um, I would love to have someone that I could uh, um, contract to make some analyses on that. Do rivers affect sand dunes like ocean waves? Well, not like, maybe not like ocean waves, but there's sand that comes from rivers. And a lot of the sand, for example, in Puerto Rico and the beaches in the north, comes from rivers. And so the rivers erode the rocks inland. And when you come to the mouth of the river ends in the ocean. And so through that delta, or through that connection between the river and the ocean, you have a lot of sand that moves onto the beach. So that's really important to consider, because when you have a reservoir in a river, uh, all those dams that we build, they keep the sand inland. And so it could cause a lot of erosion on the coast. So dams can be a problem, especially it happens a lot in California. A lot of dams have been a problem have caused dune erosion. Um, see another question here. What made you choose coastal geomorphologist as your profession? Well, when I didn't even know I wanted to study geography. I wanted to study architecture first. And now that I think about it, architects think about space too. So I guess I've been drawn to thinking spatially for a long time and hadn't realized it. Um, but then I took a geography class and I loved it. And then the class that I loved the most, or the professor that I loved the most, was a coastal geomorphologist. And so she took us to a field trip in an island that we have in the south of Puerto Rico called Caja de Muertos. And so she brought all these instruments, and we were measuring the beach in the water, and it was so much fun. I still have pictures about that. And I was completely in love with all that we did on that trip. And so I decided to do that. I really liked it. Um, Later on, I decided to study coastal dunes, but first it was the beach. So being outside and doing the field work, that was really fun. So that's what science should be, right? It should be fun. So that's why I stayed in geography, and that's why I chose coastal geomorphology. That's a really interesting question. In the map of Puerto Rico, why are the coastal dunes only in the north? That's a very important question. They are only in the north because the north is the only location that meets all of the dune criteria. In the northern side of the island, you have the beach framed by the Atlantic Ocean. So the Atlantic Ocean provides strong waves that are strong enough to build a wide enough beach. And these waves are so strong in the northern part of Puerto Rico because we have the trade winds. And so those are our constant winds, planetary winds. And you don't have those in the south. Another thing is that in the northern side of Puerto Rico, we have our biggest rivers. And so those rivers provide a lot of sand to build wide beaches. And so the combination of trade winds with wide enough beach and the wave energy that allows for that energy to work the rocks and the sediment and create small sand particles. All of that together allows for the north to be the only location where we have dunes on the island. The same thing happened with other Caribbean islands. Only the Atlantic Ocean side of the islands would have dunes. So for Barbados, for example, you only have dunes on the eastern side of Barbados. On the Caribbean side of Barbados, you don't have no dunes. So you don't have dunes everywhere. You need to meet the criteria for dune formation, and those criteria are really important. Um, More questions. Are sand dunes built going from land to sea or from sea to land? They're built from sea to land, right? You need onshore winds to move the sand landward. How do sand dunes get buried so that we find old sand underground? Um, I wouldn't say that sand dunes get buried, but maybe my advisor would say otherwise. Here in Puerto Rico, for example, you do get stable dunes, and you do get that in New Jersey, also in other parts of the US. They get stable enough that they don't move, right? And that happens when a lot of vegetation um, grows on them. Here in Puerto Rico, they don't get buried, but over time, we do have really, 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 really old dunes that have become rocks, right? And we call them eolianites. And we have them in the northern part of Puerto Rico too. And they also mark, or they, where they are is kind of like gives you an idea of where the beach used to be, right? Because if those are all dunes, then it means that there must have been a really wide beach in front of them long time back. So when you look at all dunes, they talk to you. They talk to you, they speak about what things used to be like before, long time back. Um, is there a lot of sand at the bottom of the ocean? Would that mean there were beaches there once? Well, not necessarily because sand moves around, right? When you get a hurricane, um, sand moves everywhere. It moves inland, it moves uh, onto the ocean in different locations. So having sand in the bottom of the ocean is just a part of a bunch of processes. It doesn't necessarily mean that there were beaches there once. When you see a dune, a really big dune, uh, consolidated, right, like the Aeolianites I'm describing, that definitely gives you a hint that there used to be a beach there before. Because if there were no beach, there were no dunes. Remember that to have dunes, you need to have a beach, right? So if there's a remnant or a there's a really old dune there that has become a rock and it's really big, then there's a lot of sand that needs to have been there before for that dune to form. So that's a hint of where the beach used to be. Is beach erosion a problem in Puerto Rico? Is beach replenishment ever done? Beach erosion is a problem in some parts of Puerto Rico, yes. Um, we can't say that every beach is in the process of erosion. We can't say that every beach is going through the same severe erosion as some beaches in Puerto Rico. Every beach is different, and we have to be careful when we implement mitigation activities because sometimes we want to implement what's been done in other places, and sometimes those places are not compatible with the place that we want to implement the mitigation activity in. So we have to be careful about that. Um, we mm, I don't think we have had a beach replenishment project. We've had other things. For example, close to the airport, actually north of the airport, they implemented a mesh type thing that they put some, I what do they call that? It was like a I'm thinking in Spanish. Patty, help me out. Una malla. How do you say that in English? Ah, a
I'm at
net. Gracias,
net.
gracias. Hey, you have a net, a bunch of nets in the beach to allow for sediment to accumulate faster. And but they only did the first uh part of the process, and when they didn't do the second part, then that was a problem, right? Because it didn't work as they thought it would. They had to do the entire process for it to have the results that they wanted. So I don't know why they didn't go all the way through. What kinds of animals live in the dunes? Are they an important habitat? Yes, definitely. It depends on where in the world you are. In New Jersey, you have a bunch of different kinds of insects, and you also have rabbits. In other places in the world, you can have cows. Um, Here in Puerto Rico, you have iguanas. You have what else? Of course, a lot of iguanas that are not even endemic here. You have a lot of bees, a lot of ants, a lot of crabs, birds. Um, you have roaches. You have, yeah, they are a really important habitat, definitely. And there are a lot of animals that live under the sand that you don't really see, that they're, you don't really realize that they are there. They use that space. A lot of birds, actually, in the tropics, need the vegetation on the dunes. What kinds of what type of tools do you use to measure the width of the beach or the height of the dunes? Well, right now there's a lot of GPS type things. You know what GPSs are that are used to to measure the width. It's tricky because if you have a very vegetated dune, it's hard to get a signal from the satellites. So you have to choose your tools depending on what the characteristics of your dune are, right? Um, You could use a level and a a oy, I'm thinking Spanish again. It's like a bar with a lot of measurements in meters, and it's like that you use to measure the height, and then you use a measuring tape to measure the width. That's the basic stuff. But now there's a lot of technological new things that you can connect to your um, geographic information systems in your computer, and you can type the characteristics right there in your GPS and then connect it to your computer and get all of that information right away and then just start gathering the data. And that's really faster than it used to like what it used to be before. There's also lasers that you can use to measure distance, but that's tricky also when you have a very vegetated dune. It's not very helpful when you have trees in the middle, etc., right? That happens in the tropics, not in New Jersey dunes because you don't get any trees, you get shrubs, for example. But in tropical spaces, it's you have to choose wisely what are the tools that you're gonna use. Why is the sand on some beaches different colors? Well, it depends on where the sand comes from. Usually sand that comes from rocks that are black, is black, right? In Hawaii, for example, you have a lot of volcanic rock that is dark black, right? And so that's a really new basaltic rock. And so when the rivers erode all of that rock, it ends up in the beach. And so it is the color of the rock that it came from. When you have really white beach, like in some of the beaches here in Puerto Rico, those are coral reef um, sands, right? Usually mostly biogenic sand. And that's what makes it really white because it used to be animals, right? It used to be coral, and so now it's a skeleton, a pulverized or fragmented skeleton. And so also it can come from the fish when they poop, right? And this sounds funny, but it's true. You have a parrotfish, for example, it eats coral, and it poops sand. And so because it ate coral, right, the sand is going to be white, right? And I know the coral reefs have a lot of colors, but what's inside is the skeleton that's actually white. So that's why the sand from coral reef is white. That it's called biogenic sand. Do you think it would be more beneficial for people not to develop the coastlines in the future? Well, that's a uh, that's a tricky question, right? We've already developed a lot of buildings. We've already built a lot on the coastline. And I don't think the problem is building on the coastline. I think the problem has to do with how close to the shoreline we are building. Um, and how much we pretend or we intend or we forget that the beach is a dynamic space. People get worried when they go to the beach in the winter and it's really narrow, and they get really happy when they go to the beach in the summer and it's really wide and it hasn't been replenished, right? Because replenishment is something else. But when it happens from a physical process, it's a normal thing, right? Beaches usually have a cycle, and that cycle is yearly. It happens every year when the waves get really energetic throughout the year, and that has a lot to do with the um, with the temperatures that change throughout the year, right? When it's colder, the the waves have more energy, and we can talk more about that some other time. But why does that happen, right? But usually when it's colder, waves have more energy. And so it allows for the sand to be reworked and for erosion to happen. And then when it gets warmer, the waves soothe out, right? And they have less energy. And so they're able to bring the sand back if the sand is available. Right? So all of that dynamic is normal for the beach. Erosion is a normal processes until we interfere with that process, right? Until we put a barrier, for example, or until in a barrier in the transport in the transport area where the sand is supposed to go through, right? Or when we built a parking lot or a building too close to the water line, too close to the shoreline. And so that building is immovable, right? That building is not dynamic like the sand. And so it's not compatible with the dynamics of the beach. So it's a contradiction, right? We want to be really close to the water line. We don't want to walk too much to get to the water to sit at the beach, but we are putting at risk the processes that allow for the beach to be there. And so when you go on vacation, and we all want to go on vacation, right? When you go on vacation and you take a look at the picture of the place that you're going to, it looks this way. And then when you go there, it's completely different. It's a very narrow beach, and you go like, what happened here? Well, time happened. You built too close to the water line, you built too close to the shoreline, and you altered, right? You changed the dynamics of the beach. And so that beach is not going to be the way it used to be. And you say, well, maybe we can replenish it. Let's bring sand from somewhere else. Well, that's really costly, and that doesn't last very long because and you have to be really careful with which sand you're putting there because it has to be compatible with the energy of the beach, right? So it's a lot more complicated than that. And now with sea level rising, which is inevitable and is already happening in certain places, we have to rethink the way we use the shoreline. And it's getting a little late, to do that. We might have to move buildings backwards, and nobody wants to hear that, right? So landward, I mean. So it's complicated. But yeah, we have to think about the compatibility between buildings and static buildings and the dynamics of the sand. The sand is not there to stay still. The sand is there to move, and it's normal for it to change locations. That's your geographical part of it. It needs to move. That's how the beach works. Which place in New Jersey has the highest rate of beach erosion? I don't know that one. Maybe Carl knows. I would have to ask him. Yeah, he probably knows. I can't answer that one. I would have to look it up. Yep. I would assume. Yeah, no, I can't tell. I'm not gonna assume anything. I have to look it up. So, Ryan's mom, I owe you that one. Have you ever seen any sharks? If yes, where did you see them and what kind were there? No, I haven't seen any sharks. Lucky me. I've seen barracudas. Uh yeah, those are scary. Yeah, no sharks. No sharks for me. Are there any snakes in the dunes? Um, Maybe in the tropics. I haven't seen any. There are spiders, really cool spiders. There are ants and bees, mosquitoes. Um, yeah, there's a whole bunch of insects and other reptiles, iguanas and lizards and no turtles, but yeah, other reptiles. I guess that's it. Let's see.
All right. Thank you, Rosana, Dr. Grafals. Thank you so much
You're welcome.
for a very interesting talk and in a very different perspective. We had people come and talk about turtles and talk about the ocean and talk about sand dunes before, but not from the perspective of geography. So we have learned a lot today. Thank you
Good.
so much. And to all of our audience, we hope you enjoy our Ask a Geologist series. We started last March, and today is the last Ask a Geologist for this semester, this academic year. So we're very happy celebrating a year of success to be connected with you, to have you as part of our museum visitors virtual. And we are going to be working on putting together more programming for the fall. We have late nights coming up. We're going to be working in our next open house. So please stay tuned with us in social media. And we have to thank Ria, Matt, um, Julie, who are all behind the scenes all the time. And from Lauren and I, museum directors, we hope you have a great summer and that you'll learn from all the wonderful speakers that we had this year. We're very excited to come back in the fall and maybe we can have some events in person. So enjoy your summer, everybody. And thank you, Dr. Grafals, for a very exciting
You're
talk.
welcome.